Welcome to Pre-Calculus, Sequences and Series here. In this video, we're going to talk about geometric sequences. So far we've had an introduction to sequences. We talked about arithmetic sequence, and the second type of sequence that we're going to explore is a geometric sequence. Let's jump right to it. A geometric sequence is one in which each term value increases or decreases by a common multiple. So arithmetic, we're adding or subtracting a common number. Here we're multiplying by a common number. So in this first example, we see 3, 12, 48, 192. We're clearly not increasing by the same numbers. This is obviously not arithmetic. But what am I doing? Oh, I'm multiplying. 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. 192 times 4 is 768. So I have a common multiple here of 4. I'm just multiplying every term by 4. So to get to the next term, multiply by 4, multiply by 4, multiply by 4. In this next one, we're not multiplying by 4, we're dividing by 3. Or, remember, dividing a value by 3 could be equal to multiplying by the reciprocal 1/3. That's certainly true, right? So again, 15 times 1/3 is 5. 5 times 1/3 is 5/3. 5/3 times 1/3 is 5/9. 5/9 times 1/3 is 5/27. So we're multiplying by 1/3. So obviously you can multiply or divide, but we like to always multiply. It makes it a little bit easier to kind of just be consistent. But again, even when you're dividing, you're multiplying by the reciprocal. So make sure, even though some students will say, oh, you're dividing by 3. You're right, but dividing by 3 is the same thing as multiplying by 1/3. So notice that there's a common ratio between any two consecutive terms. So in arithmetic, we saw a common difference. Now we see a common ratio. So if I divide 12 by 3, I get 4. 48 divided by 12, I get 4. 192 divided by 48, I get 4. If you divide any two consecutive terms, you get that common ratio, which we call R. So in this case, that R equals 4. Or here, 5 divided by 15 is 1/3. 5/3 divided by 5 is 1/3. 5/9 divided by 5/3 is 1/3. So that common ratio is 1/3. So just make sure when you're finding that common ratio, you are dividing any two consecutive terms. But again, you got to divide one term by its previous term. So you can maybe take the fourth term divided by the third term, the fifth term divided by the fourth term, the second term divided by the first term. You got to make sure you go in that order. So again, it's easy to see if I just do second divided by first. 12 divided by 3 is 4. There's my common ratio. 5 divided by 15 is 1/3. There's that common ratio. And that is, common ratio is going to be really important when we move forward in finding the formula for any term. So here we go. First, I want to make sure I note that geometric sequences are exponential. So linear functions are arithmetic because linear functions go up by the same number. That's the slope. And that's what arithmetic sequence does. But an exponential function is one where you keep multiplying, right? And that's exactly what geometric sequences do. So this formula is actually really, really simple. You only need to know two values. You need to know your first term. So that's what goes out in front here. We multiply that first term. And then we need to know that common ratio R. Now, n is n, right? N is the variable in the problem. N is the any term you want to find. Now, I just want to make sure I know two things here. So one, I like to really use parentheses to make sure that we see a difference between the first term and R. So you don't have to do that, but I think it kind of gives clarity. So we have the first term, pause, times R raised to the n minus 1, where again, R is that common ratio. Now, this formula can be manipulated to actually look a little bit different, and I will explain that in the next example. But this is the generic, general form that you will see most geometric sequences in. But sometimes they could look kind of like that, but a little bit different, and I'll do my best to explain that. And again, it's actually just using some algebra techniques. So let's just jump into our first example here to see how easy this can be. So given the following sequence, find the formula for the nth term, and then find the 10th term of the sequence. So I want to find the nth term formula, that's a sub n, and then once I find that formula, hey, just plug in 10 to get the 10th term. So first off, I want you to understand that in the future, you're going to have a mix of these problems, right? I'm not going to put big red shining lights and say, hey, this is geometric, this is arithmetic. So again, when you approach a problem, you need to first decide, is it arithmetic, is it geometric, or is it other, which we'll talk about a little bit later. But you got to make sure you understand. So some kids will say, well, okay, let me see if it's arithmetic. Okay, I go up by 4, and then I go up by 12. Well, wait a minute. That's not arithmetic. Arithmetic is you go up or down by the same number every single time. So right away that wipes it out. Then you say, okay, well, 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. Oh, my common ratio is 3. And again, to find that, just divide any two consecutive terms. You could do 6 divided by 2, 18 divided by 6, 54 divided by 18. Either way, you get a common ratio of 3. And then, of course, we do need to know our first term, which is pretty obvious, 2. And that's it. Those are the only two things you need to create the formula. The formula is, for any term, it's the first term times, and again, I like to use the parentheses, my common ratio 3 raised to the n minus 1. That's it. Now, please make sure you do have that n minus 1 right here. Some kids will forget that. Let's just check, right? Let's just check and make sure that the fourth term is 54. So I'm going to go ahead and plug in 4 to find the fourth term. So that's 2 times 3 raised to 4 minus 1, which is 3. So I get 2 times 3 raised to the third. 3 raised to the third is 27. If you need your calculator for that, feel free. And then 27 times 2 is 54. So this does confirm that the fourth term is 54. So there's my formula to find any term I want. All right, now let's go ahead and do the other thing it asked. It did ask to find the 10th term. So let's go ahead here and find the 10th term by just plugging in 10. So I have 2 times 3 to the 10 minus 1, which is 2 times 3 raised to the 9th. And I definitely gonna need my calculator for this one. I cannot do that in my head. So 3 raised to the 9th is 19,683 times 2. And I get 39,366. So really, really big. So geometric sequences do get really, really big very, very fast. All right, now I do want to make note of something. This right here is the official formula, but as I mentioned earlier, you can manipulate it a little bit to make it look different. So to understand this, let's do a quick little algebra lesson, just very, very quickly here. So if you have n to the 7th, and you say, okay, that's easy. And if I say, okay, well, what does that mean? That means there's 7 n's. N. Okay. So what if I take one of those n's away and just kind of put it out in front? Well, then I have 6 left. So again, but we know mathematically that this is n to the 7th. If you have n to the 1st times n to the 6th, you add the exponents n to the 7th. But it's the idea that, I could take one of those away. So it's kind of similar idea that let's just say we have 5 to the n. Okay, so notice a little different here, right? But again, same idea. I have 5 to the n. So you say, well, how many 5s is that? Well, I don't know. It's 5 to the n. It all depends what n is, right? But again, imagine if I say, okay, bottom line is you got a bunch of 5s. Let's take one of them away. If I take one of them away, I have how many left? Well, I had n. You took one away, so I have n minus 1 left. Pretty easy. So what I'm trying to say here is that we could take this formula right here. This is a great formula. It's an awesome formula. I love this formula. But I can manipulate it a bit, right? So for example, if I have 2 times, now again, I have 3 to the n minus 1. So how many 3s are there? Well, it all depends what n is, right? But there's a lot of 3s. Again, it all depends what n is. But imagine if I take one of those 3s away. Just take one of those 3s away. Don't throw it away. Just kind of set it to the side. How many 3s are left? Well, I had n minus 1 3s. I took one away, so now I have n minus 2 3s, right? Because I had n minus 1, but I subtracted one away because I didn't throw it away. I just kind of put it up front here. So now I have 3 to the n minus 2. So now I could do 2 times 3 is 6 times 3 to the n minus 2. So this formula looks different. It looks different than this formula in blue, but it actually is the same. It really is. All I did was do a little bit of manipulation. Again, if you don't believe me, let's check that fourth term again. So if I plug in 4, I have 6 times 3. 4 minus 2 is 2, so it'll be 6 times 3 to the second power. That's 3 squared is 9. 9 times 6 is 54. So again, the formula still works. I just manipulated it to make it look a little different. And I can even do it again, right? The whole idea is that, if you just look at this formula right here, and you say, well, how many 3s are there? Well, it all depends on n. But again, I could just borrow one of those 3s. I can move it out in front. And then I got to understand that I took one away. So now I had n minus 1. Now I have n minus 2. Now, why am I showing you this? I'm not trying to complicate your lives, but I'm just trying to show you that sometimes you may see this and you might say, well, That's not how the formula is supposed to look. There's supposed to be an n minus 1 in the exponent. Well, you're right. That's how the formula starts off. But with a little bit of manipulation, I could put an n minus 2 there. So here's what I really want to kind of say at the end of this is that you need to be exponential, right? Exponential means that your variable is in the exponent. Anytime your variable, in this case n, is in the exponent, it's geometric, guaranteed to be geometric, okay? So this is how we officially write it with the first term times the ratio raised to the n minus 1, but you can manipulate it a little bit if you wanted to. Now, I wouldn't ask you to do this on your own, but the point is I might give you a slightly different looking function or sequence, and it really be the same thing. All right, let's get away from that for a second. Let's just try another example here. So once again, if I'm seeing this problem for the first time, I'm thinking, okay, is it arithmetic? Well, let's see here. It goes down by 45. 60 minus 45 is 15. Well, then it certainly doesn't go down 45 again, so it's not arithmetic. And then you say, well, what am I dividing? So am I multiplying by something? So again, just divide any two consecutive terms. So take 15 divided by 60, and 15 divided by 60 is 1/4. So it looks like that's my common ratio. I'm multiplying by 1/4. 60 times 1/4 is 15. 15 times 1/4 is 15/4. 15/4 times 1/4 is 15/16. And you start to see the pattern develop pretty quickly. Again, but you could divide any two consecutive terms. So I divided the second term by the first term. But again, you could take the third term divided by the second term. Now again, you know how much I hate double fractions. So of course I would take 15/4. Instead of dividing by 15, I would multiply by the reciprocal. Hey, 15s cancel. I get 1/4. The common ratio is 1/4. And the only other number you need to create the formula is the first term, which is 60. And with these two things, you're really set for life here. So any term I want is going to be the first term, 60, times r, which, is 1/4. So I'm actually not going to write r, I'm going to write 1/4. The common ratio is 1/4 raised to the n minus 1. So there is the formula. And they also had a follow-up that they wanted me to find the 8th term. So to find the 8th term, I'm going to go and plug in 8. So I get 60 times 1/4. Now you could write 8 minus 1, or that's pretty easy math to do in your head. 8 minus 1 is going to be a 7 there. And again, definitely going to want to grab my calculator here. So 60 times 1/4 raised to the 7. Now I do get a decimal, 0.00366, but again, please, I always like exact answers if possible. And again, use the feature of your calculator to change a decimal to a fraction. We get 15 over 4,096. I love exact answers a lot better than decimals. So the only time I'm okay with the decimals, you really have no choice. The calculator cannot convert it. But always try to convert it to a fraction and give that answer if possible. All right, so the only other thing I want to mention about these previous two problems here is that in this problem, we were getting bigger because we were multiplying by a number bigger than 1. We were multiplying by 3, multiply by 3, multiply by 3, so we're getting bigger and bigger and bigger. Here, we're getting smaller and smaller and smaller because we're multiplying by 1/4. We're multiplying by 1/4. We're multiplying by 1/4. And when you multiply by a number less than 1, you're going to get smaller. So we do have two different types of geometric sequences. So they're all geometric, but we do have growth and decay. And if you should have learned this back when we talked about exponential functions, because again, geometric sequences are exponential functions. So again, we got growth and decay. So growth is if your R value is greater than 1. Decay is if your R value is between 1 and 0. You're decaying. So pretty easy, not too complicated there at all to understand that. So it's just really, are you going up or are you going down? Pretty simple. All right, so this next type of problem we're going to look at here is actually a really, really good one. These tend to be kind of the harder problems on tests and quizzes for students, so I really want to make sure I take time here. So these problems could involve arithmetic or geometric, actually. It all depends. Just got to read the problem. So here's an example of this. And again, remember the end goal is to find a formula for the nth term, right? Find the formula for the nth term. All right, so here's the information. The second and fifth term of the sequence are 3 and 24. So we're not giving you the sequence. We're not giving you the first term, the second term, the third term, fourth term, fifth term, whatever. We're giving you kind of just two random terms. So we have the second term and the fifth term. And they want me to find an explicit formula for the nth term. They want me to find that nth term formula. Now, they want me to do this problem two ways. One is if it's arithmetic or if it's geometric. So let's separate this. So let's do this problem if it's arithmetic. So remember the formula for an arithmetic sequence to find any term you want. Very easy formula. It's the first term plus that common difference times n minus 1. Now, n is always n because that's your variable. So I need to find the first term and I need to find the common difference. So here's what I know. Let me write down what I know. I know the second term is 3 and the fifth term is 24. So the question is, how the heck can I find the common difference? Because you need to know two consecutive terms to kind of see that common difference. Well, we can with a little bit of algebra. So here's how I think about it. If I am the second term, I need how many differences to get to the fifth term? Well, that'd be 3 differences, right? If I'm if I'm that second term, I need to get one difference will take me to the third term. A second difference will take me to the fourth term, and a third difference will take me to the fifth term. So the second term plus 3 differences would get me to the fifth term. So starting out with this kind of generic idea is going to be very, very helpful because guess what? I know the second term is 3. I know the fifth term is 24, so I just created a little bit of an algebraic equation to solve to find that common difference. So I'm going to subtract 3, so I get 3d equals 21. I'm going to divide by 3, and I get, that's pretty easy, I get a common difference of 7. So I now know my common difference is 7. So that's awesome. Now the other thing I need to know is the first term. Well, again, let me kind of go back to that algebraic thinking. I know that the first term plus 1 difference is the second term. Now I also could have done the first term plus 4 differences equals the fifth term. Again, I know the second and the fifth term, so I could use either one of them, but I'm going to go ahead and use this one right here. That is for the second term. So again, the first term plus 1 difference, but wait a minute, I now know what the difference is. It's 7, so 1 times 7 is 7, equals the second term of 3. So subtract 7 over to the other side, and I get that the first term is -4. So there it is. I found the 2 things I needed. I needed the common difference, which a little bit of algebra helped me find that, and I needed the first term, which again, a little bit of average. Now, a little bit of algebra helped me find that. So I just want to show you this other one works as well. So the first term plus 4 differences, well, 4 differences, I know the difference is 7, so 4 differences would be 28. 4 times 7 equals 24, the fifth term. And then again, subtract the 28 over, guess what? You get -4. So either way it shakes out, you get -4 for that first term. So now I'm just going to sub everything in to get my formula. So the first term is -4 plus that common difference is 7 times n minus 1. And to be honest, that's a great final answer. I would never mark that wrong. But I do encourage you to clean that up. Distribute the 7. So if I do that, so I'm getting a little bit messy here, I get -4 plus 7n minus 7. So that would be 7n minus 11. And again, I encourage you, when you're all said and done, you think you got your final answer for any term, go ahead and plug in 2 just to make sure you get 3 as that term. So if I plug in 2, 7 times 2 is 14. 14 minus 11 is 3. It does work. Let's even check the fifth term while we're at it. 7 times 5 is 35. 35 minus 11 is 24. So it's always worthwhile to check at the very end that you got that correct. So what a cool problem, right? And you know how much I love algebra, so of course I love that problem. All right, let's do the exact same problem, but this time we're going to consider, hey, what if it's geometric? All right, so here I go. Once again, if they're telling me that this is a geometric sequence, a formula for any term is the first term times that common ratio to the n minus 1. So once again, n is always n, that's your variable. I need to find the first term, and I need to find the common ratio. So once again, let's start with what we know. We know that the second term is 3, and we know that the fifth term is 24. So again, I gotta think algebraically, right? How can I find that common ratio? Well, remember, with geometric sequences, you're multiplying. So here's my thought process. If I'm the third term, I need to multiply by, well, I'm sorry. Second term. I know the second term. So if I'm the second term, I need to make 3 multiplications, right? I need to multiply by r to get to the third term, multiply by r again to get to the fourth term, multiply by r again to get to the fifth term. So that'd be r to the third to get to that fifth term. Again, 2 plus 3 is 5. So again, if I start with that second term, I would need to multiply by r, or r to the third to get to that fifth term. So again, of course, now I'm just going to substitute in 3 for the second term, r cubed equals 24 for the fifth term. Once again, a little bit different than arithmetic, because arithmetic you're adding to get to the next term, whereas with geometric you're multiplying to get to that next term. So again, I'm going to divide by 3. R cubed equals 24 divided by 3 is 8. Now, how do you get rid of a cube? Well, a cube root, or a cube root is the same as a 1/3 power. Again, 3 raised to the 1/3. Multiply your exponents, you just get r. So again, raised to the 1/3 power. Encourage you to use your calculator unless you know this, but the 8 to the 1/3, which is the cube root of 8, is 2. So boom, there's your common ratio. Now, that's good. That helps me find r, but now I need to find the first term. All right, so once again, I got to think kind of, algebraically here. So I'm going to say, okay, well, the first term times r to the first is the second term. Again, right? Okay. If I have the first term, times it by 1 ratio, and I will get to that second term. Or, again, you could use the other one as well. The first term times r to the fourth would get me to the fifth term. Again, multiplying. If I have the first term times r, times r, times r, times r, that'll give me the fifth term. So I could use either one of these. I don't know the first term, but I now know that the common ratio is 2. 2 to the first is 2. Equals the second term, which is 3. So again, now I just got to solve, and I get divide by 2, I get 3/2. So my first term is 3/2. Now, just to prove this other formula works as well, once again, the first term, I don't know what it is, but I do know my common ratio is 2. 2 to the fourth is 16, equals 24. 24 is the fifth term. Divide by 16, 24 divided by 16. Guess what? Both of those numbers are divisible by 8, and I get, it reduces to 3/2. So regardless, I get 3/2. So now I'm going to go ahead and fill in the blanks. My formula to find any term I want is the first term, 3/2, times my common ratio of 2 raised to the n minus 1. So there is my formula to find any term I want. So please really take the time reviewing these problems. These are problems that kids do get wrong quite frequently because they just are bad at algebra. How many times have I told you guys that? All right, now we've now talked about arithmetic sequences in the previous video. Spent a lot of time in this video talking about geometric sequences. Now, the third category is other sequences. So in my opinion, this is me, right? You might not find this in the textbook, but in my opinion, if you're not arithmetic or you're not geometric, then you're something else. And we kind of lump all other sequences together as something else. And there is no formula for other sequences, right? We have formulas for arithmetic. We have formula for geometric. We don't have a formula for any other formula, for any other sequence. So you got to just kind of figure it out on your own, to be honest. You got to use your brain, right? There's no formula to find any term. You have to figure it out. So if we look at this formula here, I'm saying, okay, 0 is the first term. So it goes up 3, then it goes up 5, then it goes up 7, then it goes up 9. So it's clearly not arithmetic, because arithmetic, it goes up by the same number every single time. And it's not geometric either, because 3 divided by 0 is undefined. 8 divided by 3 is 8/3. 15 divided by 8 is not 8/3, right? I'm not multiplying by the same number each time either. So how do I figure this out? Well, these are the hardest ones. Now, you're not going to see a ton of these, but these are the hardest ones because you just have to use your brains. And maybe pause the video and try to see if you can figure it out. But this is a pretty tough one, but it's actually n squared minus 1. And if you don't believe me, let's just try it out, right? 1 squared is 1. 1 minus 1 is 0. There's your first term. Second term, 2 squared is 4. 4 minus 1 is 3. Third term, 3 squared is 9. 9 minus 1 is 8. So there you go, right? Now, again, you might be saying, I would never figure that out on my own. Well, again, I'm telling you, I know. If it's not arithmetic, if it's not geometric, they're hard. You got to do something on your own. You got to use your own brain power to try to figure it out. That's all I could suggest to you. And in this case, it's a square minus 1. And sometimes you just got to see it. 16 squared, or I'm sorry, 16 minus 1 is 15. 25, which is 5 squared, minus 1 is 24. 36, which is 6 squared, minus 1 is 35. You just have to see it. And I really can't tell you anything else. Obviously, we're going to work on some of those in class to kind of get better at them, but lump them into 3 categories. Arithmetic, easy. Arithmetic, I got a formula. First term plus common difference times n minus 1. Easy. If it's geometric, easy. First term times the common ratio to the n minus 1. So simple. If it's not arithmetic, not geometric, you need your brains. All right, see you in the next video.